So let's dive into a detailed explanation of the code which we have used in our project. It's displaying on the screen. So firstly, brasher.h and servo.h are the header files that provide necessary functions and definitions to control the robotic arm and servo motors respectively. Then moving on to the lines which are showing on your screen, that is the servo base, servo shoulder, servo elbow. These are the lines which declare servo objects for each joint of the robotic arm, which is base, shoulder, elbow, wrist rotation, wrist vertical, and gripper. Moving on to the link lengths, these constants represent the lengths of the robotic arm links. L1, L2, and L3 correspond to the lengths of the shoulder, elbow, and wrist rotation segments, respectively. So now this is the void setup and void loop function. In the setup function, the serial communication is initiated at a baud rate of 9600 for debugging purposes. Then a delay of 1000 milliseconds, that is 1 second, is added for stability. And then the brachio robotic arm is initialized. Then in the loop function, the end effector of the robotic arm is moved to three different positions sequentially. For each position, the coordinates x and y of the end effector are set. Then the inverse kinematic function is called with these coordinates to calculate the corresponding joint angles using inverse kinematics. A delay of 5000 milliseconds, that is 5 seconds, is added to allow the arm to reach the desired position before moving on to the next one. This loop continues indefinitely, causing the robotic arm to move between the specified positions repeatedly. So now let's understand the void inverse kinematic function. So we'll understand this function step by step. So the first thing is function definition. This function, inverse kinematic, takes two float parameters, x and y, which represent the desired position of the end effector of the robotic arm. Then moving on to the next one, which is calculating angle gamma. Gamma is calculated using the tan2 function, which computes the angle between the positive x-axis in the point x, y in radians. This angle is then converted to degrees using the degrees function. Then adjusting for link 3. The coordinates x2 and y2 are adjusted to account for the length of the third link, L3. This adjustment ensures that the calculation considers the end position of the second link. Then calculating distance. The distance d from the adjusted point x to y2, which we did earlier, to the origin is calculated using the Pythagorean theorem. Now the next thing is checking reachability. Now the code checks if the desired position is reachable by comparing the distance d with the combined lengths of the first and the second links, that is L1 plus L2. If the distance is less than or equal to the sum of the lengths of the first two links, the position is considered reachable. Then we calculate the joint angles. If the position is reachable, the code calculates the joint angles theta 1, theta 2, and theta 3 using the cosine rule of triangles. Then finally, the calculated joint angles are used to control the servo motors of the robotic arm with the brachio rod servo movement function call. This function essentially performs inverse kinematic calculations to determine the joint angles required to position the end effector of the robotic arm at a specified XY coordinate. So, in short, this Arduino code controls a robotic arm using inverse kinematics to move its end effector to specific positions. Thank you.